All right, everyone. Let's say you just walk through the door, right? And in front of you, you see this dude who represents College Board of ACT, right? They're staring at you like, what are you doing here? And you're like, well, let me explain to you something. Oh, that's what you do to questions. Uh-oh, there's geometry coming at you. Geometry. Let's see algebra. Oh my. Let's see data analysis and advanced math combined together. We might as well just look down at data analysis and advanced math. Oh my. The danger, the destruction that you guys will commit to that exam. I want you guys to beat the test. Little by little, you do your business, you beat down the SATs. All right, we're in geometry, page 404. I hope you found that a bit entertaining. Let's go into the questions immediatamente. All right, question number 17. This would be considered, I'd say, borderline medium and hard level question. We see a circle. What do we know about circles? We always have 360 degrees in any circle is given to us. We see two lines that are intersecting. If they're intersecting the circle, we know that that has to be the center of the circle. The other thing that we know that the angle SOR is going to be equal to the angle of POQ. Got it? And then we also have the vertical angles. SOP is going to be equal to ROQ. Basic ding dong rules. We see figure not drawn to scale. We like that, which means that they have to give us enough information to answer that question correctly. Now we go into the question. The circle has a center O, which you already know. The circumference is 144 pi. So that means the entire measure from, let's say, R all the way around back to R is going to equal what? 144 pi. The entire distance all the way around measured. It could be inches, centimeters, whatever it is. It's just a measurement going all the way around. This is the diameters PR and QS. Those are the two black lines intersecting the middle. All right, we understand that. Now, the length of arc PS. Arc PS is this guy here to here, that arc is twice the length of arc PQ, P and Q. So it says that that is a 2-to-1 ratio, which means if we have vertical angles, the opposite of 2, that would be also a 2-to-1 measurement for the length measurements to these guys, including the angles. You guys got that? All right. Now, if I have 144 pi going all the way around, what would happen if I divided all this by 6? Because what is 2 plus 2 plus 1 plus 1 equals 6? If I divide 6 into 14 or 144, I'm going to get 2 and I'm going to get 4, but also pi. So that means the part that shows a measurement of 1 is 24 pi, and the other part that shows a measurement of 1 is also 24 pi. Now, what are going to be the 2's? Well, that's 2 times 24, which is going to be 48 pi, and the other one is going to be 48 pi. If you added all those up, 24, 24, 48, 48, which are in 1-to-2 ratios, you add them all up, you will get 144 pi. The question is asking, what is the length of RQR? And RQR is all of this business going on here, so therefore we already know is 48, and that's our answer to the question. Next question, number 23, is supposedly hard. Yeah, they say it's hard. It's in the 20s. We know they get a little dirty there. Now they're showing us circle formula rules. Let's go into the world of circle formulas. Remember, this is a properly stated circle formula in which on the right-hand side, the equal sign, they're showing you your radius, but it's that 16 is not the radius. That is a number that is squared. However, if we were to square root that number, what would we get? We would get the radius of 4. Remember, outside the equal sign, it is squared. So we must square root it to get our radius. Now, on the left-hand side of the equal sign, they're showing us our coordinate points. Let's go with this x minus 5. If I set x minus 5 to equal 0, then x would equal 5. So that coordinate point for the center of my circle is 5. So what's going to be my y coordinate? Set that to equal 0. Y minus 3 equals 0. So y equals 3, positive 3. So my coordinates for the center of my circle is 5, 3, and my radius is 4. If I were to draw this on an xy coordinate plane, let's go with the center of our circle. I go 1, 2, 3, 4, 5, but I got to go upstairs 3 times. 1, 2, 3. Here's the center of my circle with a radius of what? 4. So I can go to left, 1, 2, 3, 4. So that's the left-hand side of my circle. Go right, 1, 2, 3, 4. I can go south, 1, 2, 3, 4. That's the bottom. And 1, 2, 3, 4. That is the top. And there is my circle. So if you plug that formula into Desmos, it's going to show you an image that looks very similar, not as ugly, as the image on the right. I'm writing this out for you so you understand the parts and the pieces so that when you do plug it into Desmos, you have a complete understanding of what you're seeing. All right, now the question is saying, what is the diameter of the circle? Well, if the radius is 4, that means the distance from this point to the center is 4. If I continue going through that from the center out to the other edge, that's going to be another 4. So what is 4 plus 4 equal to? Bang, our answer is 8. This was a hard question in a previous test. Could be PSAT or ACT or SAT, and they decided, oh, let's put it deeper in a test. A lot of students answered incorrectly because it's hard for a lot of students. But really, it ain't that hard. Question number 21. It's also considered a hard question. The circle in the XY plane has a diameter. All right, remember diameter, not radius. Diameter, that's from one end of the circle through the center to the other side of the circle with endpoints 2, 4, and 2, 14. Hey, I don't trust myself. I'm immediately going to draw an XY coordinate plane and I'm going to hash out these measurements. I'm going to go out 2, to the right 2, positive 2, but I'm going to go upstairs 4 times. 1, 2, 3, and 4. So there is one coordinate point of what? My diameter, and then 2 and 14. So I'm going to go out 2 again, right? Out 2, but this time I'm going to go upstairs 14. So I already got 4. Here's 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Let me write that 14 there because that one was 4. So there's my other coordinate point for what? My diameter. So if I draw a line connecting it, I know somewhere around the center, I've got to have the center of my circle because this is the diameter of a circle. So somewhere around the middle of that line, I'm going to have my center. Now, how can we be accurate finding it? Well, take a look. They gave you the formula. What is our center coordinate for our x? X minus 2 equals 0. Our center coordinate for x is going to be a positive 2. What's our center coordinate for y? Y minus 9 equals 0, so y equals a positive 9. Let's go to the center. I'll use green to go to the center. We got to go across 2 from the origin, 1, 2, and then I got to go upstairs 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the center of my circle, that yellow dot. Cool. All right. So now, what is going to be the radius? All I have to do is count my distance, right? That's going to be 5, 6, 7, 8, 9. It's a distance of 5, which means this is going to be a distance of 1, 2, 3, 4, 5. So my radius is 5. So if r equals 5, then that means I got r squared, which will be equal to 5 squared. Get rid of the squares. What's my r equal to? Ding dong. And that is it. Question number 24. This is also considered a hard question. Let's diggity dang. Let's hit this question. Each of the answer choices are showing you formulas for circles. And since these are formulas for circles, notice on the right-hand side that we talked about, for each one, we have radical 16, which would make our radius 4. Each one of these, we have to square root, square root, square root, and they're each going to be 4 for our radius. Basic ding-dong rules. Now, I'm going to do answer choice D first to show you our center coordinates. When you see x squared, set it to equal 0, and then x would just simply equal 0. What about our y coordinate? If I do y minus 9 equals 0, then y equals a positive 9. So this question is asking, why is it a hard question? Because of the setup. Which of the following equations represents a circle in the xy plane that intersects the y-axis? So it has to intersect the y-axis at exactly 1 point. Not 2 or 4, 1 point. Let me draw this xy coordinate plane. You know what? I'm going to do answer choice D first. What is the center of our circle? It's going to be at 0 and positive 9. So let's go out 0. Oh, that's right in the center. Let's go upstairs 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the center of our circle is going to be right there where it is at 9. Now what's the radius? It is 4. 1, 2, 3, 4. Let's say 1, 2, 3, 4. And down south 1, 2, 3, 4. And to the west 1, 2, 3, 4. If I were to connect this, right? Connect the radii, I'm going to have a circle, but it's supposed to intersect the y-axis at exactly 1 point. Is this intersecting the y-axis at exactly 1 point? No, it is intersecting exactly 2 points. So D cannot work. That's what this question is asking. So one of those answers can only touch the y-axis or kiss the y-axis at 1 point. The answer to this question would be C. All right, what's our x coordinate? It is 4. Let's go out 4. 1, 2, 3, 4 for the center of our circle. And what's our y coordinate? We're going to go upstairs to positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is the center of our new circle. Now we got a radius of 4. 1, 2, 3, 4. That means it's touching the y-axis. Go out here. 1, 2, 3, 4. Go south. 1, 2, 3, 4. Go north. 1, 2, 3, 4. And there is your circle. Now, is it kissing the y-axis at exactly 1 point? Yes, sir, indeed. So C is your best answer. Was it really that hard? All right, when students are using Desmos, they're going to be plugging in their answers into Desmos, and it's going to show you perfectly drawn circles. But notice you got 4 different answer choices, and those 4 different answer choices are going to give you 4 different non-overlapping circles, so it can get a little confusing. In this case, if you're going to plug in each answer, plug them in from the bottom up, because more than likely a question like this, they like to bury it down low rather than give you the answer at the very top. All right, next question, number 25. This is also considered a hard question. All right, how bad is this sucker? Let's take a look. We see the answer choices. Oh, there's such a pattern with these questions. And notice they're mostly all high numbers. If they're high numbers, then we got to get prepared for the toughest circle questions. Now, if you're taking a test at the last minute, do you really have to know how to work these? No, not really. But after you take the test, let's say it was tomorrow, then over the next 4, 5, 6, 7 weeks before the next test, man, you can own these type of questions. All right, let's take a look at what we got so far. They give us an equation. Now we know our coordinates is going to be what? We just reviewed this. What's our x value? X squared equals 0, so x is going to equal 0. And what's our y value going to be? Y minus 1 equals 0, so y equals a positive 1. Now, what is our radius? We must square root this sucker, so our radius is going to be 7. There's the center coordinate point, 0, 1, and a radius of 7 for our particular circle. Oh, we got to take a circle B and shift down. All right, let me do an XY coordinate plane. Because you can enter that formula that I just popped up there into Desmos, and then you see a perfect circle. So if you got your computer screen or another on your phone, maybe you could actually plug it into Desmos and see what it looks like. All right, so let me do 0 and 1, 0 and positive 1. So that means the center of my circle is going to be at positive 1. Let me just mark that as 1 with the radius of 7. I'll just quickly do it. 1, 2, 3, 4, 5, 6, 7. So that's going to be my right side. I can go down south. 1, 2, 3, 4, 5, 6, 7. Let me do a quick one. 1, 2, 3, 4, 5, 6, 7. That'd be my left side, and upstairs 1, 2, 3, 4, 5, 6, 7 from the red. All right, if I connect this, oh, this is rough, but you guys get the idea. Oh, it's not too bad. Bang. That is my circle, the center at the red dot at 0 and 1. Cool. Now the rest of the question where they telling you, oh, we got a circle B, yo. Because that circle B is obtained by shifting circle A down 2 units in the XY plane. Okay, let me see if I could create a circle B right quick. Let me duplicate. Let me change the color. I'll make it red, Fred. All right, let's move this circle back into position. Boop. So that's the original circle. Circle A is green, but right, you got a circle B, which does what? It's going to take the circle and shift down how many units? 2 units. Let me see if I can capture that red dot. I think I got it. Ready? Now I'm going to shift this sucker down 2 units. 1 and 2. Now where's the center of my circle? The center of my circle is going to be at coordinate what? 0, comma, negative 1. So that means my 0 for my formula still remains the same. It's going to be x squared. Always in the middle, it's going to be what? Plus. Now, if your y equals a negative 1, then inside the parentheses, it's going to be y plus 1, and outside goes squared. Did your radius change? No, but your radius is always displayed as being squared. So what is our radius? It is 7. What's 7 squared? It is 49. Take a look at your answer choices, which one matches up with it, and they buried it down low. Dirty, but very good question. To go over basic fundamentals of circle formulas, this is a very good question to do so. All right, let's move that booty to the next question. Question number 13, no circle image given to us and no answer choices. Oh, they're getting mean, but it's a question number what? 13, which means it's a medium level question. I think we own this. Now, this is a combination of using triangles and circles. Let's see what we can do with this. A circle has a center, O, and points R and S lie on the circle. All right, let's first draw a circle. I'm going to draw a black circle. Bang, Suzanne. There, I got my black circle. It has a center of O, I'll mark it as O. It's not perfectly centered, but you know what I'm talking about. Now, this part where they say points R and S lie in a circle. I think it was the previous page, page 3 or 4. We had something like this where we had to figure out where's the R and S. They don't really tell us that there is a point RS. They just said angle ROS. That means when I see this, I'm putting a 1 o'clock position and a 3 o'clock position approximately. I'll put my R and I'll put my S. Whenever I see this type of question, I always go 1 and 3 o'clock for the points. They could give you different letters, it doesn't matter. Go 1 and 3 o'clock. All right, what's the basic fundamental of this stuff? We know that if I drew a line from the center out to the blue dot, that is a what? A radius. If I drew a line from the black dot in the center to the blue dot, that is also known as what? A radius. We cool? All right, next. In triangle QRS, what? Triangle QRS? This is what they mean by that. Triangle QRS, ready? In triangle, ORS, I'm sorry, ORS, O, we draw a line to the blue dot. From the blue dot, we go to the other blue dot. And from the blue dot, we go back to the green dot. Whoop. There's your triangle. Now, what do we know about a triangle that has two equal sides, R and R? That means it must have two equal angles. You guys got that? See how they're squeezing in triangle information into this particular question? All right, now I got two equal angles. And then they tell me that angle ROS is going to be this guy right here. ROS is going to be this angle here. They said it is 88. So how many degrees do we have in any triangle? 180 degrees. They tell me that I've got 88 degrees angle ROS. Let's subtract 88 degrees. And what do we have left over? 10 minus 8 is 2. 17 minus 8 is going to be 9. 92 degrees to be shared with this corner and this corner. So they got to be equal to each other, two equal sides, two equal angles. So what is 92 divided by 2 equal to? It will equal 46. And that is the answer. So angle R is 46 and angle S is also 46. But they want RSO. So RSO is all about the S angle, which has to be 46 degrees. Next and last question. Now, I pre-drew this, right? It's been pre-drawn. Why? Because I had to do this video like 4 times because I kept on messing up this question when I was drawing it. And this computer wasn't really acting well with me. Plus, now it's shorter, the entire video. Plus, I included that scene from a Bruce Lee movie. Oh, I love what I do. All right, here we go. Question number 26. Oh, this is meant to be dirty hard, right? So we expect it to be dirty hard, but it's going to be based on simple fundamentals of circles. A circle in the XY plane has a center at -1 and +1. So where's our -1 and +1? So x equals -1, which means we're going here to the blue dot. And then we got a +1, which means it's going upstairs. So the red dot is the center of my circle. That's -1 and +1. Then the next bit of information they tell us is that there, yeah, I'll do it in green. That line T, now we got a line that is tangent. All right. Side information about the word tangent. All right. Whenever you see the word tangent involving circles and lines, not involving triangles, we're involving circles and lines. Oh, come on, man. Is this freezing up on me again? Oh, this is not fair. Anyhow, whenever you have circles that involving tangent, right? Whenever it involves tangent, then you're dealing with basic fundamentals of geometry as it involves circles. I'm going to draw a circle. If they say that a line is tangent to the circle, check this out. That means a line could be floating in space and it's going to go like this. It's going to kiss the edge of the circle. When I say kiss, I mean literally kiss the edge of the circle like this. When that happens, let me blow this up a little bit. You see the center of the circle? All right, if I drew a line from the center of the circle out to where the point of where it kisses, it forms a 90-degree angle. Got it? That's the whole point about tangent. The black line is tangent to the blue circle. That means it's just kissing the circle at one point. Now, that black line, as it relates to the radius of the circle, forms a 90-degree angle. If you know that, you kill any question that involves tangency. Killed it. It doesn't involve SOHCAHTOA. Circle lines deal with kissing line on a circle or kissing a box on a circle, kissing a triangle on a circle, which circles dealing with the triangle in a square. or a box is dealing with straight lines, right? The edge of a box or the edge of a triangle. All right, now let's go into the rest of the question. Line T is tangent to the circle at point 5 and -4. So let's go to 5 and -4. So I'm going to go outside. 1, 2, 3, 4, 5. And then I got to go downstairs, -4. 1, 2, 3, 4. So my point is going to be right here for that point of the line where it's kissing the circle. Now, remember the example I gave you upstairs that the center of the circle is kissing the edge of the circle with the line? So if we go to the center of our circle that we had drawn originally, and I drew a line from that red point down to where it kisses the circle to that point, that is the radius of the circle. All right, here's a big, all right, well, hold on. Let's go to the question. It says, which of the following points also lies on line T? So that green dot is a line kissing the circle, but we got a couple of steps to do. Let's figure out what the circle would look like. All right, would look like. First of all, let's figure out what the radius is. See that distance, that red line distance? What is that distance? Here's how you would find it. I call it triangulation. If you take that green dot and you went north, right? So you can make an immediate left turn, a immediate 90-degree left turn to that red dot, the center of the circle. How many spaces would you go up? There's 1, 2, 3, 4, 5 spaces up. So it's a rise of 5. And how many points to the left would you go to the red line? That'd be 1, 2, 3, 4, 5, and 6. That's 6 paces. Guys got that? So it's a rise of 5 and a run of 6. All right. Now, if I wanted to figure out the other point where I create a 90-degree angle with this particular radius here with the center, because I want to find the next coordinate point that would be the radius right above my green dot. So all I have to do, now check this out. Now I'm not going to go up 5 over 6. Now I'm going to go up 6 to get the other end. Ready? 1, 2, 3, 4, 5, 6. Now I'm going to go across 5 to the right. 1, 2, 3, 4, and 5. So this point right here is the other end from the radius. If I drew a line from the center of the circle out to this point, bang, that is going to be the radius of the circle. So let's say I just created a curve. Oh, I can estimate the other one's going to be over here somewhere, right? It's going to be over here somewhere. And I can prove if I go down 6, 1, 2, 3, 4, 5, 6, and then I go across 5. 1, 2, 3, 4, and 5. Ta-da! And I could draw. I'm just showing you some basics because you guys see that this stuff is really not that hard. They want you to get really confused by it. In fact, I'd say if you saw a question like this, remember it's question number 26, is it really worth doing? Because it's only worth the same number of points. All right, as an easy question. So if I were to connect this, right, this would be one side of my circle. Hopefully it straightens it out. Oh, that's ugly. Hold on. Let me do that again, man. Let me do that again. Bro, technology. I'm not that great with this, but you get what I'm trying to say. Oh, now it doesn't want to do the work. All right, forget it. All right, so if I have my circle, that side of the circle, now my line is going to be touching that circle at that green dot that I had drawn initially. Here, let me mark it in black. This is where the line is touching. Now, where that line is touching, it's like, but how the heck do you figure out what is the slope of the line? What is the rise over round? What's the y equals mx plus b? Remember that when the line is kissing, it forms 90 degrees. Here, take a look at this guy over here. It forms 90 degrees with the line and the radius. So that means that that black line is going to be parallel to a line that would be going through the diameter of that circle. We already have that right here. So that would be replicated, right? The 2 green points, which forms the diameter, would have to be the same rise over run from that black point. What was the rise over run from the black? That would be from the black point. Remember, it's up 6. 1, 2, 3, 4. I got a delay on the screen. Hold on, let me see if it shows it. Oh, I think my memory is dying on this. Or maybe it's the college board. 1, 2, 3, 4, 5, 6. And then I would go across how many? I go across 5. Ooh, big time delay. Let's go across 5. 1, 2, 3, 4, and 5. So my line would be crossing through here, just like that, going straight through and kissing the circle right at that. I'll color in blue right there, is kissing the circle right there. All right, so what would be that coordinate point that I got to going up 6 and across 5? It doesn't look like it's going to be this guy. It doesn't look like it's going to be that guy. It kind of looks close to this one, but your answer is C. Yes, it's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we go upstairs 2 times, 1 and 2. And that's it. That's how you work that question. Now, you have to think the big picture, right? If you're taking the SATs, is this a question worth sitting on? This is a slow down question. Is there a faster way of doing this on Desmos? I'm sure there's a faster way, but what's the safest way for me is doing it by hand because it's so much easier to see. And plus, when you practice doing it by hand, you get very familiar with the basic fundamentals of circles and all that business. Now, we've covered in those 4 pages, in those 4 videos, everything that we talked about was about lines, quads, triangles, and circles. If you do this before the next exam, if you're taking it in the last minute, you're going to feel much more comfortable. So if you have any questions, subscribe to this channel to see any upcoming videos where I break down additional information. If you have any special requests, you can text me at 786-877-7231. In the meantime, take care and have fun. Bye.